Welcome. Today's notes worksheet is entitled Expressions with Rational Exponents. We're going to see some pretty complex expressions today in this particular lesson, and we're going to see if we can find some good algebraic ways to manipulate them and break them on down and simplify and so forth here. So I'll try to explain this using some simpler expressions, and then we can kind of build up to this to the more complicated ones. So let's see, there's an investigation at the top there, and let me read what we have and go forward. After we factor out a GCF from an expression, what calculation can be used to determine the terms inside the parentheses? Use the example to answer this question. So nice and simple here. If I asked you to go greatest common factor on this, you know, I don't think you'd have too many issues. It's 12 and 30 there. You would take out the 6. X to the 5th and x squared, especially after what we've been kind of talking about all unit here, that would be x squared. And once that greatest common factor comes out, the question really is what goes there and what goes there. And, you know, when the numbers are pretty simple and the values are pretty simple, you can do this without too much issue. You would say, you know, this times something has to give me that, this times something has to give me that, and you can probably figure what goes in here without too much issue. But what if you can't? That's what I need. How can you use what you have here to determine this right here? So I guess one way to think about this is, you know, it is the distributive property. This times something gives me that. So 6 times something is 12. Or another way to kind of talk about that is 12 divided by 6 should give me that right there, right? And x squared times something would give me x to the 5th. Or really this divided by this tells me what's in here. Multiplication and division go hand in hand. So I guess long story short here, I would look at this and say, well, 12x to the 5th divided by 6x squared should tell me what I need to multiply this by. 12 divided by 6 is 2, hence 6 times 2 is 12. X to the 5th divided by x squared, of course, is x cubed, and same thing, this times this is that. And so you can kind of see with a little quick division, I got that piece. Same deal on this end, everyone. I had 30x squared. I took 6x squared out. And so this times something gives me that, or this divided by this gives me what's left. 30 divided by 6 is 5. This is x to the 0, which is just 1. End of story. And you get that. So here's what we're going to write in, and hopefully it'll work out as these expressions get quite a bit more difficult with their numbers. So here's what I have. Take the original term and divide it by the GCF. And that's pretty much it. Again, and this is only if you're unsure of what goes in here. If you just can't quite pull it off. You know this times something has to give me the original. If you can't figure out what that something is, I'm just trying to give you a more formal approach to pull that off. So let's go ahead and work with our rational exponents here. Starts out relatively simple, and then as you can see there, it kind of builds up in difficulty. Well, let's see what we can do. So here we go, 2 terms separated by the minus. What I'd like to do is manipulate that expression and write it in its factored form. It does say write your answers with positive exponents. We'll be careful on that with a couple of these. So let's start it out. What is the greatest common factor of x to the 3/2 and x to the 1/2? Well, what we found very simply is that for any particular base, the greatest common factor is going to be the lower power. In this case, x to the 1/2 is the lower power. So out it comes. Now, again, I kind of do the reverse of the distributive property, so that comes out. What would be left in as part of our remaining factor? And so again, if you're not sure, this times something gives me that. I don't know. I would just work off to the side, and I'm just saying this if you can't quite pull it off just mentally. And so that's what I would be thinking of right there. So x to the 3/2 divided by x to the 1/2. The original divided by what we pulled out. Keep the base, of course, and subtract the exponents. 3/2 minus 1/2 is 2/2, which is 1, so it's x to the 1st. I'm going to put just a little 1 right here, but obviously we know x to the 1st is just x. Okay, and then here's my minus. Same thing. If you just don't know, and this one shouldn't be too bad, but this times something gives me that. If you're just not sure, just trying to give you a way to pull it off. And you would say, oh, okay, well, Mr. Meyer taught me to keep the base and subtract the exponents. 1/2 minus 1/2 is 0. Oh, wait a minute, x to the 0 is 1. And so you get that. And we all know, of course, anything divided by itself is 1. And so there you go. I mean, that's factored form in a nutshell. All right. So I'll keep working off to the side. If you don't need to, you can obviously do what you can here and then just fast forward or whatever. But two terms separated by that plus. Let's write this as a product of its factors. Greatest common factor of 4 and 8, 4. Greatest common factor of x to the negative 2/3 and x to the 1/3. Wow, tough fractional exponents here, but I'm just going to go with our conclusion that we've developed. It is just the lower power. So it should be 4x to the 2/3. And so now, of course, what I need to do is figure out what's remaining inside the parentheses. And if I can't pull it off, if I can't think about this times something gives me that, and this times something gives me that, well, again, that's when we work off to the side. I will do that. So I've got the original divide by what we pulled out. There we go. Okay. So here was the original. Here's what I took out of it. That should, the answer when I divide should give me that piece. 4 divided by 4 is definitely 1, and anything divided by itself is 1. So I'm hoping you saw it was a 1 anyway from the beginning. All right, so I have my 1. Here's my plus right here, and I do the same thing. Not sure about this one, but there we go. Looks good. 8 divided by 4, guys, should give me 2. Now this is a good one. Again, just good arithmetic. This divided by this is keeping the base and subtracting the exponents. 1/3 minus negative 2/3 should be 3/3. Hope you're okay with that. 1/3 minus negative 2/3 is 3/3. 3/3 is 1, so it is 2x to the first, or just 2x. And that would be the case right there. And again, you're always more than welcome to just go ahead and distribute it in. If you do, you would get this right here. Now, I guess I would ask you, in this case, just the way we've been developing expressions this whole unit, could you go further? Yeah, you probably could. So it's this times this times this. This is just what's striking me at this stage. It's a term with a negative exponent. Remember, it's only the x that has it, not the 4. So it seems like that's going to go on down. And again, I guess just better expressed using that positive exponent there. And now we can really truly see numerator in contrast with the denominator. So the x to the 2/3 comes on down. All right, good. Let's continue. Let's do C and D. Hopefully, again, just the more practice with these, the more you're seeing it. I do have 2 powers of the same base. And so if I'm looking for the greatest common factor, it is very simply the lower of the 2 powers. Negative 5/3 is definitely the lower one right there. So we're going to take out the x squared plus 3 to the negative 5/3. Now again, just not sure what's going in, so I have to kind of figure it out. So this is what I pulled out. This times something gives me this. I don't know. I have no idea what it may be. So I do know, based on what we developed, this divided by this would tell me what's left inside. And that's what I'm going to do, everybody. I'm just going to work off to the side here. And it is all in the same base. And we have a lot of experience dealing with that stuff right here. So I guess the question is, of course, what would that be equal to? And so, again, we keep the base, x squared plus 3. We subtract exponents, negative 2/3 minus negative 5/3. Subtracting a negative, of course, just like adding a positive. Negative 2/3 plus 5/3. Oh, wait a minute. That's 3/3. 3 over 3, guys, is 1. So the exponent here is 1. That's the key, guys. Have to be able to pull that piece off. So now it is really just x squared plus 3 to the first. And anytime we have it to the first power, well, remember, it is just itself. It is just x squared plus 3. Now I'm hoping you see, in this case, I pulled this whole thing out. So this times what is going to give me this? Well, I am hoping you see that would be 1. I could do it off to the side again if you want, but essentially you knew this had to be 1. Anything divided by itself is 1. Okay, well, let's clean it up. A lot of simplification here, just deals with seeing what you have and then cleaning it up from there. I have this remaining factor, and I just see that as x squared plus 4, combining like terms, of course. And again, it looks good. I just would say it can be a touch better. The x squared plus 4 is great. Nice sum of 2 squares there. But how about we bring that x squared plus 3 now to the 5/3 in the denominator. And there you go. All right. All greatest common factor, but really taken to the next level for sure. All right, letter D. Let's see if this one works. Okay, so one term with some stuff in it. Another term with some stuff in it, separated by that plus right in the middle. Let's see if we can get a greatest common factor here. And again, if it helps you, I've told students over the years, maybe just circle that, and then circle that, and then see what is common to both of those. In terms of the 8 and 10, I'm seeing a factor of 2 come out. And let's see, I have a 4x plus 3 to the negative second. I have a 4x plus 3 to the negative first. I would take the lower one, of course, as the greatest common factor. So it doesn't matter what the exponents are. That's the nice thing about what we've developed. We basically said the greatest common factor is the lower power. And so that's looking good right there. And now we've got to clean up what's going on inside. All right, I don't have a ton of room here. I'm going to try to find it, though. Take the original, divide by what you pulled out. And by the way, you know, I see this 5x plus 1 here. Obviously, there was no 5x plus 1 here, so I don't know. Maybe we could have done a few things to it. Maybe multiplied it in. I don't know, just kind of thinking out loud with that, but I like what we have at this stage. So let's go for it. This is what I had originally. This is what I pulled out, excuse me. And now we have to just think about what's left. 8 divided by 2 is 4. This divided by this is just 1. So I think we get a 4. Okay, good. Now the next one is really the issue. Here's what I had, 10 and a 5x plus 1 and a 4x plus 3 to the negative first. And then down here, what do we have? The 2 and the 4x plus 3 to the negative second. All right, so what I start with and what I pulled out. Now, I don't have a ton of room here. I'm going to go this way. 10 divided by the 2 is going to be the 5. Hope you see that. This divided by that. This divided by really just 1 is just that. Well, I really didn't leave myself a lot of room, but I'll try to find a way to get this going. And then this divided by this, everyone. Let's see. Can we pull that off? Divide powers with the same base. We subtract the exponents. Negative 1 minus negative 2 is positive 1. And so we get 4x plus 3 to the first. So not ideal, but there it is. I'm going to have to clean that out momentarily or kind of work this way, but we'll see. So it looks like, wow, this is crazy, but that's what I have left. I have a factor of 5 left. I have that factor of 5x plus 1 left. And I have a factor of 4x plus 3 left. Interesting. Okay. Now I guess I would ask you, let's kind of shortcut this a touch if we can. Could you clean this up if I made you? Could you multiply all this together and then maybe add the 4? Yeah, I mean, I'm hoping you could pull that off. Could you then bring this on down right here as a factor with a negative exponent, bring it down to a denominator? Yeah, and I'm hoping you could do that as well. So I'm going to give you what happens here. The 2 is a factor. This piece, just all cleaned out, gets a little crazy, but I get this. And again, you're more than welcome to kind of pause the video and test yourself a little bit, see if you can pull that off. But, I'm just kind of looking at the clock here, and I don't know. Let's save our energy for the stuff that's a little more important than this piece. But I like this. I'm thinking that's pretty cool. Nice. The key is, can you find the greatest common factor? Because now obviously they're quite a bit more intricate. And then can you use that greatest common factor and figure out, well, if this is what we started with, this is what I pulled out, what am I left with? Okay, good one. Let's move on. Example 2. Even though this is a lengthy problem set, it's pretty quick. So it says a prelude to the next type of problem, just perform the operation. Just watch what happens here. And again, these expressions they get manipulated pretty nicely. When all is said and done, the answer should look pretty decent. And that's the point. You're kind of simplifying some pretty complex and comprehensive expressions. Okay, well, let's do it. 4 plus x to the 1/2 times 4 plus x to the 1/2. Multiply powers with the same base. You keep the base, and you add the exponents. 1/2 times 1/2. 1/2 plus 1/2 is 1. And so, guys, just without too much issue, should be 4 plus x. Take a look at it in its radical form, because we're going to see that. Now that we have two different representations, isn't this basically the exact same thing as this right here? Square root of something is raised to the 1/2. And, I guess square root of anything times the square root of that same term, isn't that just x plus 6, long story short? And you can see it from two different vantage points. Again, one in radical form, one in exponential form. Cool. Hey, divide powers with the same base. We've already kind of seen this already. Keep the base, subtract the exponents. 4/3 minus 1/3 is 3/3. 3/3 is 1, and so you can see it's just x minus 2. And that's what's happening here, of course. Do the same thing here, everybody. Look at what we have. Look at the division, and keep the base. 2/3 minus negative 1/3 is 3/3. Same deal, guys, just to the first power. And that's what's going to happen with most of these. We saw this already. They're even going to get more complicated, but just trust it that it should work out nicely. Keep the base, work with the exponent, but what you're going to find is these exponents should clean out nicely. So negative 2/3 minus negative 5/3 is negative 2/3 plus 5/3, which is 3/3. And so it's 6 minus x. Again, I'll do it one more time all the way through. That would be this, which obviously is to the first, and which is obviously this. And that's what we're looking for. Okay, so a very quick problem set just to kind of make sure we really see it. And that's what we're doing, kind of multiplying things together. Should work out cleanly. Specifically, you'll see a lot of the division on these bases, and when all said and done, it should look pretty clean. You're not going to get crazy stuff left over. All right. So an investigation and an example 3 to kind of round this out here, as a matter of fact. And I would argue that this problem is going to mirror this. This one, fairly simple. This one, a little more complicated. Same deal here, guys. This one, fairly simple. This one, quite complicated. So we're not even going to do the math on the investigation. We'll save it for example 3, but we'll write down what we would do in the investigation. So it says, write an expression as a single quotient. Describe how you would simplify each expression. So writing it as a single fraction and making sure it's simplified. So in this case, I have two things really added together, and this is a fraction, and this obviously I can create as a fraction. So are you okay with the fact that I would probably add these two together, obviously to create a single fraction out of it, and I would find the LCD. And I think that's pretty much what we want to do. And the LCD, which would be x plus 1, just kind of looking at it, and combine the fractions. And that's it, right? does say to add the two things together, and I add two fractions together by finding the least common denominator and literally then being able to combine the fractions. So find the LCD and combine. I like it. That's it. That's all we need. Okay, now if you would do that intuitively here, then there's no reason why this should be a hard problem for us. So I'm going to put this over 1, and I'm hoping, again, you see the similarities. It's the only reason, just trying to be visual about it. Something you've done many, many times before, now something that's a little harder but looks basically the same. So LCD, guys, let's go ahead and get that going. I'm going to just write it off to the side. And I'm looking at these two things, and I hope you would agree that the LCD is that 2x to the 1/2. And so that's all I'm going to do, guys, is just write this as 2x to the 1/2. That's great. Now remember, even though these are a little more complicated, the process is still the same that we've been developing all semester long. Let's go for it. I made these two fractions into the common denominator. How did I change the denominator? Then I have to compensate by doing the same thing for the numerator. So denominator is the same, so that's good. Numerator is the same. So you know that top left portion has to be 1 plus x. Now, guys, let's watch this one. How did I change the denominator? Old to new. It looks like I would multiply this by 2x to the 1/2. So that means I have to take the numerator and multiply it by 2x to the 1/2. Hope that makes sense. Now we're going to have to clean this out just a little bit. I'm running out of a touch of room on my screen here, so I'm going to bring this on up. And I get 1 plus x plus, ooh, this is kind of interesting. Now think about the front side, because we did this. I'll have the 2. I hope you all agree there's a factor of 2 in there. What is x to the 1/2 times x to the 1/2? Should be x to the first, right? Just like we saw on the front side. Keep the base, add the exponents, 1/2 plus 1/2 is 1. And that's great, because now it's just a 2x over that piece right here. And I'd clean up the numerator a touch. And how does that look as a simplified single fraction? I'm going to box that up, and that's looking perfect. Cool. I hope that helps. So again, if you can shortcut this or streamline it a little bit and get to here, great, 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 great. All right, so that would be two fractions that are really begging to be added or subtracted, and you just do it. LCD, put them together, even if they have fractional exponents. All right, now letter B. What's interesting, guys, is this actually already is in a single quotient. But the thing is, it's not quite simplified just yet, I guess, completely simplified. I mean, it looks good, but I would argue we can work with it a little bit and do some things. And so how would I work with this particular single quotient here and simplify it? Well, I'm thinking the only way I can simplify fractions is to cancel out common factors. Now, the bottom is just a monomial, That's nothing I can work with. But the top, of course, I can factor that. So that's what I'm going to do is factor either the numerator and or the denominator. In this case, it is just the numerator. And cancel common factors. We've done this before many, many times. So let me just make sure I have this right for you. Factor the numerator and or the denominator and cancel common factors. Okay, or just, work with it in whatever way you can. But that's the idea, is we've got to break it down into factors first and then see what presents itself. Okay, so we're going to do that for part B right here. And so notice it just say simplify each expression. This is pretty ugly. Let's see if we can work with it a little. And it does say write your answers with positive exponents, so we'll keep that in mind. So guys, look at that top right there. Circle that very lightly if you want, or better yet, circle the two terms separated by that minus. Here's one, and then here's one right here, and let's see if we can work with it. And I see it, just like I kind of saw it up here, that there is a greatest common factor to these two terms. It just happens to be the power base x squared plus 4. And so I'm going to take out the x squared plus 4 to the negative 1/2. Remember, the greatest common factor is the lower of the two powers. And then let's see what we have remaining over that x squared plus 4. And by the way, just because I'm dealing with so many powers of that base x squared plus 4, I'll go ahead and put that as well. I don't know if that's helpful yet, but we'll see. All right. Now, guys, you've got to get good at this. So I'm not going to write it off to the side. If you need to, please do so. But this is what I started with. This is what we pulled out. What's left? This divided by this. I keep the base, and I subtract the exponents. Again, we've had a lot of practice, even just on this notes worksheet with this. 1/2 minus negative 1/2. Well, it's 1/2 plus 1/2, which is to the first, and so it's x squared plus 4 to the first in there. Minus. Hope you see that we never touched this x squared right here, so that is still in there. And didn't we take this entire thing out? It's out. There it is. And again, a good way to check. This times this is that. This times this is that. We did it. And guys, now we factored it, and now what we want to do is see if we can clean things up. Simplify what's left in there. I'll let you do that momentarily. And then how about this piece right here? I have factors or powers with that same base. Let's see what we can do with it. So you can subtract them. You can bring this down and multiply them together. I mean, it's up to you here. I would love for you to pause and see if you can simplify it. And then I'll give a quick verbal explanation as to how that pulls off for the final answer. Okay. So inside, the x squareds actually cancel, right? So I'm getting just a 4 on the top. And then what happens here, either way, this divided by this, negative 1/2 minus 1 is negative 3/2. So I have x squared plus 4 to the negative 3/2. Don't like those negative exponents, so it comes down and it's positive. And wow, look at that. Look how much simpler that is compared to what we started with. And it is an equivalent expression. This is the same as this right here. All right, look that one over. If you're not sure about something, please never hesitate to ask, especially that last piece. What I did is I just divided those two powers with the same base and kept the base, subtracted the exponents. I got negative 3/2. So if you wanted to write x squared plus 4 to the negative 3/2 right up here first, that's fine, but then it comes down and becomes positive. All right, last one. Let's see, it's very similar to the previous one. So in this case, I am actually going to do it. I'm going to circle that one, and let's see if we factor it and kind of work with it a little bit, see if we can simplify. All right, greatest common factor. I see an x actually in both these, right? Here's an x. Here's 3 factors of x. So there we go. And I've got this power with that, or this base raised to that power, this base raised to that power. Take the smaller. So x squared to the negative 2/3. Okay, now let's see what's left. So again, see if you can do this without writing it off to the side. If you need to, please do so. This divided by this. Well, 2 divided by 1 is 2. X divided by x is just 1, so that doesn't help. And then this divided by this, same deal. Notice they are going to work out well. So I see that it's 1 minus x squared. 1/3 minus negative 2/3 is 3/3, again to the first power, so it's just 1 minus x squared. All right, now the plus. Same deal, guys, we repeat. Let's just go ahead and do that, divided by that, and see what's left. I pulled out a factor of x from here, so x cubed divided by x is x squared. This divided by itself is just 1. And so, wow, very, very cool. I think we have some good things going here. How does that look? Just initially factored, pulling out the greatest common factor, and then going from there. Okay. Well, I'm going to do just a couple things that I see. If you want to jump the gun a little bit, please do so, and then see if you get it right. So, first order of business, guys. Let's clean this up a touch. You know, the 2 would distribute in. I'd go ahead and do that. And I'll go ahead and do this in several steps just to make sure we really do see everything coming together. So I have a 2 minus 2x squared plus the x squared. That's in there. And then 1 minus x squared to the 2/3. All right. Let's do a couple things here. The x is just happy as can be. It's not doing anything except just being a factor by itself. And then let's see inside here, I've got the 2, and I'm seeing minus x squared. Negative 2x squared and 1x squared make negative 1x squared. That's looking great. And then, since I didn't do it last time, I'll do it this time. But I would divide those 2 powers. Definitely can do that here. So I think it's ready. Divide those powers with the same base. So I keep the base, and I subtract those exponents. Negative 2/3 minus 2/3. Negative 2/3 minus 2/3 is negative 4/3. So you can do it that way. I've seen students over the years just be like, you know what, I don't like this with a negative exponent. Bring it on down and make it positive, and then combine down there. It should still work out the same. I come up, and let's wrap this up here. Factor of x. Factor of 2 minus x squared. And then that power has to come on down. And there we go. Look at that. That looks great. Cool. Look at what we started with. Look at where we ended. Again, I like that. Good manipulation there. And just great algebra all the way through. You can see some very, very difficult expressions to look at. But if you follow just what we've been talking about, and really it's a good challenge for us. All right, I think I'll wrap it up at that stage. Please get some practice on these. They're not easy by any means. And if some explanation was lacking for whatever reason on doing some of these problems, or if you just didn't see a particular step, let me know about it so we can look at it together. Kind of slow it down a little bit for you and walk you through. All right, well, thank you so much for listening.